Okay, next question was DNS Exam 2, problem number 8. And in this one here, they gave you a function, y was equal to x to the fourth plus bx squared plus 8x plus 1, and told you that this particular function had both a horizontal tangent and a point of inflection for the same value of x, and they wanted you to figure out what the value of b was. So let's take advantage of two things that we know right here. A horizontal tangent is going to happen anytime that your first derivative is going to be set equal to 0. A point of inflection is when the second derivative would equal 0. Now there do have to be sign changes within those as well. Just setting it equal to 0 isn't enough to prove it, but for this problem that should be good. So what I did here is I went ahead and took the first derivative of the function and got 4x cubed. Remember that b is just an arbitrary constant, so the 2 comes out in front and it's plus a 2bx plus 8, and we know that that derivative is going to equal 0 for some particular value of x. Now right next to that at the same time, I went ahead and took the second derivative of this function and got a 12x squared plus a 2b and set that one equal to 0 as well. And the important thing is here that for one particular value of b and for one particular value of x, both of these expressions are going to equal 0. Now, as is often the case, it's the second derivative that's a little bit simpler to deal with than this one right over here. Since there was a b in both of these equations, I went ahead and took the second derivative equation and tried to solve that one for b in terms of x. So I brought the 12x squared to the other side and got 2b is equal to a negative 12x squared, divided both sides by 2 and got b is equal to a negative 6x squared. That's as much as you can do with that, but now that we know that that's the value of b, I then brought that back over here into the other equation and put that in for b in a substitution. So where are we now? 4x cubed plus a 2 times our b value of negative 6x squared times that x plus 8 is equal to 0. And as luck would have it, those factors right there all multiply together to give us a negative 12x cubed, and now we ended up with two like terms that we had right here. If they didn't choose their values in this problem carefully, we could have been stuck with just some random cubic equation that would have been pretty much impossible to solve by hand. But we ended up with a very simple cubic equation, and what I mean by that is there's an x cubed term, but there's not an x squared and there's not an x. So it was a pretty easy one to solve with inverse operations. From here, just went ahead and divided both sides of that equation by negative 8, and that got us x cubed is equal to positive 1. Then took a cube root of both sides of that equation and got x is equal to 1. Now, in what was a little bit mean on their part, 1, I'm pretty sure, was one of the 4 options. But remember, that was the value of x. The problem here was asking us for the value of b. So we now needed to use that, coupled with the idea that I just zipped right by here, that b was equal to a negative 6 multiplied by x squared. So putting those two concepts together, b is equal to a negative 6 times 1 squared. B ended up equaling negative 6, so the correct answer there was A.